So the last problem wasn't really a nonlinear inequality because we didn't have any variables in the denominator. Let's do one more that's nonlinear. Here we do have a variable in the denominator. We can't just multiply by the least common denominator because we don't know whether x plus 1 is positive or negative. So we're going to have to get everything on one side, so it's equal to, so it's zeros on the other side, and then we can rewrite this as one fraction, and then we can evaluate with a sign chart. All right, so our first step is going to be to subtract x divided by 2 from both sides. So now we have 0 is greater than or equal to 5 over x plus 1 plus 4 minus x divided by 2. It made sense to move the x divided by 2 because that was only one term. All right, so our least common denominator, we have two denominators here. So we have a 2 and we have an x plus 1. So our least common denominator is going to be the product of those. All right, and I'm not going to bother to multiply those out. I'm just going to leave them factored. All right, so we've got 0 is greater than or equal to. So the first term needs a 2 in the denominator. If I'm going to give it a 2 in the denominator, I'm going to have to give it a 2 in the numerator. Otherwise, I'm going to change the value. All right, so if I multiply the numerator and the denominator by 2, that's just like 1, right? Because 2 divided by 2 is 1. And you can multiply by 1. That doesn't change the value of anything. All right, well, 4 doesn't have a denominator at all, so it's going to need the 2 and the x plus 1. Right? And so essentially we've just multiplied it by 1, right? Because 2 times x plus 1 divided by 2 times x plus 1 is just 1. And the x divided by 2 needs an x plus 1. So we'll give it an x plus 1 in the numerator and an x plus 1 in the denominator. All right, so now let's simplify, and let's write that over one fraction, because I'm tired of writing 2 times x plus 1. 0 is greater than or equal to 5 times 2 is 10, plus, that would be 8, right, times x plus 1. We can multiply those together, and then we'll distribute to that sum. And remember, you're multiplying by a, actually I shouldn't, well, let's put it like this. It's minus, right? So you might want to just change the x to the negative so that you remember to distribute a negative to both those terms. All right, so that's going to be negative x times x. Actually, I'm going to write it like this. And then I'll just multiply everything at the same time. So plus negative x times x plus 1. And that's all over, right? Since if you can add fractions with the common denominator, right? You add the numerators, keep the denominator. So I only have to write it one time now. All right, let's simplify that. So 0 is greater than or equal to 10 plus 8x plus 8. I just distributed the 8. And then negative x times x is negative x squared. Negative x times 1 is negative x. All over 2 times x plus 1. Now let's get our combine our like terms. Let's put the x squared first. Negative x squared. And then we've got 8x minus x, so that's plus 7x. And we've got 10 plus 8, that's 18. Divided by 2 times x plus 1. Oh, almost could make it without having to move over here. But I'm almost done. Let's factor the negative out because it's so much easier to factor without that negative there. So 0 is greater than or equal to negative. So in the numerator, it's going to be x squared minus 7x minus 18 all over 2 times x plus 1. All right, and that we can factor. And I'm fine where where a is 1, you can see what multiplies to give you negative 18 and adds to give you multiplies to give you negative 18, adds to give you negative 7. Well, that's going to be negative 9 and positive 2. That's going to factor to x minus 9, x plus 2, right? It's pretty easy to factor in your head when a is 1. It's when a is not 1 that factor by grouping comes in real handy. All right, so there we've got all of our factors. And let's set all of our factors equal to 0 because those create our boundaries. All right, so we've got x minus 9 equal to 0, so x is 9. So our expression here has got to be equal to 0, otherwise we can't do a sign chart. And if we can't do a sign chart, we can't solve it. All right, and then we've got x plus 2 equal to 0, because when would our fraction be equal to 0? When the numerator is equal to 0, right? And if you're going to have 0 in a numerator if you multiply anything by 0. So if I plug in 9 into this equation, 9 minus 9 is 0. 0 times anything is 0. If I plug negative 2, which is the other boundary, into the numerator, I've got negative 2 plus 2, that's 0. Anything times 0. If I got a 0 in here, that's going to make our fraction equal to 0. And we have to watch out for the undefines. So we're going to set our denominator equal to 0 because that is one of our factors. You don't have to worry about the 2. The 2 is just a 2. But the factors, right? Because if my problem is going to be negative 1, right? So if I plug in negative 1 there, negative 1 plus 1, that's 0. Up 2 times 0, up, that's 0. So that's the one to worry about. Because even if I distribute the 2, 2x plus 2 equals 0, 2x equals negative 2, x equals negative 1. So those are our boundaries. So that's going to create our intervals. Negative infinity to negative 1 is the smallest. Negative 1 to 0. Let's move that down a little bit. We're going to run into our boundaries. Oops, sorry. Negative 1's not the smallest. Negative 2 is the smallest. You can see him there. Negative 2. Negative 2 to negative 1. We have lots of little boundaries. Let's get rid of this. Negative 1 to 9. And 9 to infinity. Okay, so 1, 2, 3, 4. Let's hope I can remember that for the next page. And if I were smart, oh, there is a marker here. I could write it on the board. So our new equation is going to be the simplified one. 0 is greater than or equal to x minus 9 times x plus 2 divided by 2 times x plus 1. Because if we could have just worked with the first equation inequality, then we would have, right? We couldn't. We had to get everything on one side, right, as one single quotient, right? Because when we're dealing with one quotient, then we can determine when that quotient is 0, right? If we've got a bunch of terms, there's no way we're going to be able to figure out when it's going to be 0. But for the quotient, if the any of those factors in the numerator is 0, our quotient is 0. And if the denominator is 0, the quotient's undefined. So, and then we've got negative infinity to negative 2. I left off the negative on the first time, but negative 2 to negative 1, negative 1 to 9, and 9 to infinity. So when I change the page, I won't go, what was the numbers? It looks like I just left off the negative here. All right. No sign chart this time. This was a bonus problem I decided to do. All right, so we have, and one of the things I like is that now essentially we're dealing with a less than, right? Because our terms are on the negative side. X minus 9 times x plus 2 and 2 times x plus 1. All right, and our boundaries. So we've got, hopefully I save enough space here. I'm going to make a big box. We got a lot of factors this time. And I'm not known for my small writing. All right, so we have so this is negative infinity to negative 2, negative 2 to negative 1, negative 1 to 9. I have plenty of space. 9 to infinity. I was afraid I wasn't going to have enough space. Actually, it'd be nice if I could move that over. Nah, it's all stuck together. Now I got to squeeze. I didn't save myself enough space over here. You know what I could do? There. Give myself a little more space so I can write the factors. All right. So we want to be worried with, and I'm just going to write sign of ones. All right, so we've got and it doesn't really, let's just go in the order that they're written there, because it really doesn't make a difference. So x minus 9, x plus 2, I have plenty of space. X plus 1, there's only 3 factors. And who did I forget? Oh, the whole quotient. X minus 9 times x plus 1. I may as well write the 2 in. X plus 1. All right. Made my box too big. Really, it was only one more factor than the other problem. I just imagined I was going to need all the space. All right, so now we're going to go through each of the factors. All right, so if I plug in a number between negative infinity and negative 2 into x minus 9, all right, I'm subtracting, I've got something negative minus something negative, and minus, I'm subtracting, so essentially something negative plus another negative. Right? Of course that's going to be negative, right? And if you're not sure, plug a number in, all right? Negative 5 is in the interval there. Negative 5 minus 9, that's negative 14, all right? Everything, even negative 2 minus 9 is going to be negative. So everything on that interval is negative. You know, let's change the color. Looks nicer when there's another color. Stands out. Let's get rid of him. What if I plug it into plus 2? Right? Well, negative 2 plus 2 will be 0, right? But if I plug in something smaller than negative 2, right, like negative 1 plus, or excuse me, negative 3 plus 2, or negative 5 plus 2, I'm going to end up with a negative. Right? X plus 1. Right? Well, if I plug in negative 2 plus 1 even, that's going to be negative. If I plug in something more negative, like negative 3 plus 1, it's going to be negative. So all of these are going to be negative. They weren't that big to begin with. So you've got a negative times a negative divided by a negative. You've got 3 negatives. This is negative. Let's look at the next one. All right, so negative 2 to negative 1, not a huge interval in terms of integer values. So let's take negative 3/2, for instance. Well, even negative, we could even just take negative 1. Now, anything, even negative 1 minus 1 is negative. So something a little smaller than negative 1 is still going to be negative. Matter of fact, we're going to be negative until we get to 9 minus 9. So now negative 2 plus 2 would be 0. But if I take away something a little less than negative 2, right, like negative 1 plus 2, that would be positive. Negative 1/2, or excuse me, negative 3/2 plus 2. All right, negative 1.5 plus 2 is going to be positive. Right, so that interval is positive, right, because I'd have to, even negative 2, the lower limit is only going to take it to 0. So x plus 1. So if I plug in negative 1 plus 1, that would be 0. But negative 2 plus 1, that would be negative. So anything other than the negative 1 is going to make this negative. All right, now let's see. We've got a negative times a negative, right? Oops. When I wrote this, I put a 1 there. I mean, it really sort of doesn't make a difference, only because I got x plus 2 above. I'm not really doing anything with this other than as a column to write down the sign, but let's put the right terms in there. All right, so a negative times a positive is negative. So the numerator is going to be negative. Actually, yeah, it's fine. And the denominator is going to be negative, right? Because that's x plus 1 is negative on the interval. A negative times a negative is positive. So that's great, is positive there. Whoops. And we can probably get those out of there. All right, let's look at the next interval. All right, 0 is a great number on that interval of negative 1 to 9. All right, so the only thing that's going to actually, for x minus 9, if I plugged in a 9, I'd get to 0. But everything less than 9 is going to be negative. Lots of negatives for x minus 9. He's a negative fellow, I guess. All right, so let's plug in 0. That's on the interval negative 1 to 9. 0 plus 2, that's positive. 0 plus 1, positive. All right, so we've got in the numerator, we've got a negative times a positive, that's negative, divided by a positive, that's negative. All right, if you've got an odd number there, whether you're multiplying or dividing, you're negative. Last one. All right, greater than 9, this one's positive. This one, add something greater than 9 to add 2 to something greater than 9, it's positive. You add 1 to something greater than 9, it's positive. And you've got nothing but positive, so of course that's positive. Now, we have to consider, so we've got our intervals, right? We are less than, right? Because x is on the less than side. 0 is on the greater than side. So even though you see a greater than or equal to sign, essentially this is a less than or equal to sign, because I could write it like this. I could flip it. X minus 9 times x plus 2 divided by 2 times x plus 1. So long as I point it this way, the less than side is pointing at my x's, all right? So if you get confused, you can flip it like that. So long as you've got the same, the inequality pointing in the towards the same expression. So I don't know how you want to consider it. The small side needs to point to the x's, and the larger side needs to point to the 0 on the interval, on the inequality, right? Because this is our expression here is less than 0, no matter which side is listed on. All right, so less than 0 is this one and this one. All we need to consider now is the endpoints, the boundaries. All right, so it's a greater than, or excuse me, it's a less than or equal to. All right, so the numerator can be 0. So this one is fine. This one is fine, right? I can plug in 9, right, into, and let's do that. All right, so if I have 9 minus 9 divided by 9 plus, or times 9 plus 2 divided by 2 times 9 plus 1, that's going to be 0 times 11 divided by 20, that's 0. And that's okay. If I have negative 2 minus 9 times negative 2 plus 2 over 2 times negative 2 plus 1, that's going to be negative 11 times 0, and the denominator there we've got negative 2. And that's 0. And that's fine. Now we go plug in the negative 1. I'm just going to erase this because this wasn't really all that important. If we plug in the negative 1, negative 1 minus 9 times negative 1 plus 2, 2 times negative 1 plus 1, we've got negative 10 times 1 over 2 times 0. That's going to be negative 10 divided by 0, and that's no good. All right, so this one is no good. So yes, yes, no, because it makes the denominator 0. So if you've got an equals as part of it, you can include the endpoints, except for the one that's in the denominator. He doesn't get included. He's messing us up. So our solution, and we'll graph it too. So in interval notation, is, now I'm going to go in order, negative 2. So negative infinity to negative 2. Yes. Yes, because it's this one. So look, if we look up, and we can include the negative 2, so that gets a bracket. Sorry, just for a moment, I had to check myself. So it's this, so we're looking up, right? This is good, right? Because that's negative. It's making our expression negative. This one's good. Just don't include the endpoints on don't include this one. So yes, and negative infinity is not, it's never included. It's always, you're always approaching. So yes, no, yes, right? Because the negative one's a problem. So negative infinity to negative 2. And we've got two pieces here. And then parentheses, negative 1 to 9 bracket, all right, because 9's included, negative 2's included, not negative 1. This is an interval notation, as you're giving an interval. Set notation. It would be, here's my bracket, good enough. X such that, so we're going to be less than negative 2. Or equal to negative 2. All right, so we're going to be less than negative 2, or, so the or here means either one's okay. We're going to be, make sure I put the right one, greater than negative 1, not equal to, or less than or equal to 9. And that took me more time. Now I am fine, oops, I'll just have to leave it there because I can't move it over. I am fine with you saying it in an interval notation, but if you see set notation, you should be able to recognize what it's saying, all right? You may not choose to use it, but you should recognize what it says. All right, the or means either one's okay. It can be less than negative 2, or it could be between negative 1, less than negative 1, and, greater than negative 1, but less than or equal to 9. Boy, this one took me a while. All right. Oh, and last little bit. And you know what? They won't take you as long because you won't be talking the whole time. All right, so I need to make sure I've got at least 10 on here. All right, so, or 9, and negative 2. All right, so negative 3, negative 2, negative 1. I like to have one extra number. 0, 1, 2, 3. And I'm doing it one way. 4, 5, 6, oh no, 7, 8, 9. I just squeezed it in. Okay, so we are going to be but less, so we're going to be, so negative 2 is a closed circle. Right? I'm only doing closed circle, open circle, not parentheses, brackets. I can't do it. And they both mean the exact same thing. So we can be less than negative 2. Oops! Not 2. Sorry, I'm trying to go quickly because I saw how long this is. Less than negative 2, and that's when you make mistakes. Less than negative 2. Well, that's a lovely arrow. And between, but not including, negative 1 and 9. So not including the negative 1, but including the 9. All right, so values that aren't included, anything between negative 1 and negative 2, and anything greater than negative, and then anything greater than 9. Right? There we go. There's our solution. All right. Oh, and one little thing. Back here, I said I was going to tell you what if it had been less than. So if it had been less than, our solution would have been negative infinity to 0, including the 0, and 1 to infinity, not including the 1. Right? So it would have been the complete opposite of 0 to 1 if the inequality had been switched. So that's the end of this podcast. So a little long, but I hope that this is making good sense to you, and you might want to put this one in your notes. And in class, I would tell you that. And this is called a sign chart. We use these a lot in calculus, so a little practice now will make you good later. All right, thanks for watching. Bye for now.